Solving a linear equation with several occurrences of the variables on both sides, and fractional coefficients. Solve for v. So I have this equation here. Whenever you solve equations, I use 3 steps. The first step is to clear any fractions. And I can see here I've got 3 different fractions as coefficients. So the first thing I want to do is just get rid of those fractions so that I don't have to worry about them anymore. To clear the fractions, I need to look at the denominators. I have 2 different denominators here. I have a 4 and I have 3's. So I'm going to take those denominators and multiply them together. 4 times 3. I only need to put 3 in once. One of every different denominator, but if you put it in twice, this will still work. If I did 4 times 3 times 3, it'll still work. But I'm just going to put the 3 in once as a representative of that denominator. And when I multiply them together, I get 12. This is the magic number that is going to clear away every single fraction. So now I'm going to draw some lines to divide up my equation a little bit. And how I decide where I draw the lines is where I see pluses, minuses, or an equal sign. So I divide it into terms at the pluses, the minuses, and the equals. So I have negative 5/4 v as one term. There's the plus or minus. Then plus 4/3. There's the plus. I'm dividing it pluses, minuses, or at the equal sign. Then I divide at the equal sign. This term has a negative. And then this term also has a negative. So I have one plus or minus in each term, and then the number in the variable. I'm going to multiply every term by this magic number, 12. So I need to do 12 over 1 times this. 12 over 1 times 4/3. 12 over 1 times negative 7/3. And 12 over 1 times negative 1. And then I'm just going to multiply my fractions. So you can do 12 over 1 times negative 5/4 in your calculator. Or I'm going to cross cancel some factors here. I know 4 goes into 12 3 times. So 3 times negative 5 is negative 15. And I'm left with 1 times 1 on the bottom, or just negative 15b. I don't need to put the over 1. Now here, 3 goes into 12 4 times. So in the numerators, I have 4 times 4, which is 16, over 1 times 1. So this is plus 16. Here, the 3 will go into 12 4 times into itself once. 4 times 7 is 28. So negative 28b, 1 times 1 on the bottom. And then lastly, I just have negative 1 times 12, or just negative 12. So I did step 1. I cleared out all of the fractions. Now I have an equation that is algebraically exactly the same as that one. It just doesn't have the fractions in it. So after you clear the fractions, the second thing you want to do is simplify each side of the equals separately. So I'm going to look right side and left side and see if I can do anything to simplify things before I start solving. So over here I have a v term and a constant term. They're not like terms. I can't combine them. Nothing to simplify there. Same thing over on this side. A v term and a constant term. They're not like terms. Nothing to simplify. I have no parentheses, so I can't distribute anything either. When we're simplifying, we're either distributing or combining like terms. I can't do either of those things on either side. So I can go ahead and just jump down to step 3 now. Step 3 is isolate the variable. Or get it by itself. Get the variable by itself. Well, my variables right now are, or I have variables on both sides. I have a v on the left, a v term, and I have a v term on the right. So I need to get those together, or I need to eliminate one of these two. It doesn't really matter which one, but I only want v's on one side of the equation, not both. I like to keep my variables on the left side, so I usually eliminate this one that's on the right. So the opposite of negative 28v is positive 28v. That's what will zero it out. But if I add 28v to the right side, I have to also, to keep my equation balanced, I have to add 28v to the left side. Those will zero out, leaving me with just negative 12 on the right side. And over here, I have 28v minus 15v, which is 13v plus 16. Now, I only have variables on one side of my equation, so I'm doing good. But now I need to isolate it, or get it by itself. So I'm going to get rid of this constant term first. I'm always going to save for last the number that is directly attached to my variable or my coefficient. I want to get rid of anything else first. So this plus 16, to zero it out, I would subtract 16. And balance my equation by doing it on this other side. So 13v on the left is equal to negative 28 on the right, combining these two. Last thing I need to do to get the v by itself is get rid of the coefficient, the number that's directly attached to my variable. And this is implied or hidden multiplication, 13 times v. So to undo that, the inverse is to divide by 13. The 13's cancel, and I am left with final answer v is equal to negative 28 over 13. And I can leave that fraction improper.